Good morning, dear students. So far, we have discussed about some operations on matrices. Yes, what were the operations we discussed? Yes, what are they? Addition of matrices, subtraction of matrices, existence of additive inverse, additive identity. Now, of course one more property is there, that is a scalar multiplication. A scalar multiplied by a matrix. Now, today we will discuss about some problems related to all these operations. Okay, you can copy down these questions along with me. Now, let A be a matrix of order 2 by 3. The elements are 1, 2, 3, 2, 3, 1. Matrix B is equal to, copy along with me, matrix 3, minus 1, 3, minus 1, 0, 2. Okay, what is the order of matrix A? Matrix A is, it is having 2 rows and 3 columns. So, 2 by 3. Matrix B is also of order 2 rows and 3 columns, 2 by 3. That means these two matrices are applicable for addition and subtraction. Now, the question comes as, find 2A plus B and A minus 3B. Okay. So, in these two questions, you can see that operation addition, operation subtraction. Here 2A. What does 2A means? 2A means it is a scalar multiplication. 3B means it is a scalar multiplication of the matrix B with the scalar minus 3. So, let us first find out 2A. How do you get 2A? 2A means A matrix is multiplied. Every element of A matrix is multiplied by the scalar 2. So, what is the answer? 2, 4, 6, 2 2s are 4, 6 and 2. The same order follows. Now, the question is 2A plus B. 2A plus B is equal to 2, 4, 6, 4, 6, 2 plus matrix B. What is matrix B? 3, minus 1, 3, minus 1, 0, 2. Now, these two matrices are of the same order. When you add them, the result is also a matrix of the same order. Now, one of you give me, how do you add these two matrices? These two matrices are added by adding the corresponding elements. So, what is the corresponding element? A11, 2, here it is A11, 3. 2 plus 3 is equal to 5. Next one, I'll write that one. 2 plus 3. What will be the next one? 4 plus minus 1. 6 plus 3. 4 plus minus 1. 6 plus 0. 2 plus 2. And the order is equal to 2 by 3. So, what is the final answer is equal to 2 plus 3, 5. 4 plus minus 1 is equal to 3. 6 plus 3 is 9. 4 plus minus 1 is 3. 6 plus 0 is 6. And 2 plus 2 is 4. So, the order is 2 by 3. 2 rows and 3 columns. I hope all of you understood the question. Now, have you completed? Yes. Okay. Now, we will go to the next one. A minus 3B. So, first of all, we will find out what is minus 3B. The scalar is negative. The scalar is negative 3. Minus 3B. That is equal to minus 3 into matrix 3, minus 1, 3, minus 1, 0, 2. So, what we have to do? We have to multiply each element of the matrix with negative 3, which is equal to minus 3 into 3, minus 9. minus 3 into minus 1, 3. 3 into minus 3, minus 9. 3 into minus 1, 3. Minus 3 into 0, 0. Minus 3 into 2, minus 6. Okay. Now, the question is A minus 3B equal to, what is A? 1, 2, 3, 2, 3, 1 minus 3B is equal to minus 9, 3, minus 9, 3, 0, minus 6. So here it is plus, because minus 3 you have already found out. So it is plus minus 3B. This can be written as A plus minus 3B for convenience. A plus minus 3B. So it can be written as A plus minus 3B. It becomes easy. A plus minus 3B, because you have found out minus 3B equal to the corresponding elements 1 plus minus 9, 2 plus 3, 3 plus minus 9, 2 plus 3, 3 plus 0, 1 plus minus 6 equal to, what is 1 plus minus 9? Minus 8, 5 minus 6, 2 plus 3, 5, 3 minus 5, and its order is also 2 by 3. So I hope you have understood how to do. Here two operations are combined together. Two operations means addition and scalar multiplication. The other one is subtraction and scalar multiplication. So you can get any type of questions of this form. I hope all of you have written this question. Okay. Now we pass on. Today we will discuss more about questions rather than going to the next concept. All these questions are important because in question paper it will be like graded questions. First thing they will ask you to find out the scalar multiple, then they will do A plus 3B or A minus 3B, something like that. So it is always a graded question. Next one, take down A is equal to a matrix of, now someone has to tell me the order of this matrix. Question number 3, A is equal to 8, 0, 4, minus 2, 3, 6. B is equal to matrix 2, minus 2, 4, 2, minus 5, 1. Find the matrix X. You have to find the matrix X such that 2A plus 3x is equal to 5b. The relation is 2a plus 3x is equal to 5b. What have you to find? You have to find the matrix X. So matrix X means it will be capital X. Matrix X. Now what is the order of this matrix? Matrix A. There are 3 rows and 2 columns. It is 3 by 2. What about matrix B? 3 rows and 2 columns. 3 by 2. How many elements are there? 6 elements. Okay. One more question as a revision. If a matrix has 6 elements, what are the possible orders it can have? I taught you in the first class. If a matrix has 6 elements, what are the possible orders it can have? 1 by 6, 6 by 1, 3 by 2 and 2 by 3. Yes, very good. So 1 by 6 means it has 1 row, 6 columns. 6 by 1 means 6 rows, 1 column. 3 by 2 means 3 rows, 2 columns. 2 by 3 means 2 rows and 3 columns. It is just a review. In between I am asking you. Now, here what all properties you can see? You can see the operation addition. First one, what is the property? Addition. Then scalar multiplication. Scalar multiplication. And one more thing you can observe here is what? Yes, equality of matrices. Left side is a matrix, right side is a matrix, and these two matrices are equal. Okay, so now I am going to do in one step. 2a plus 3x is equal to 5b. What does it mean? Now that is 2 into matrix 8, 0, 4, minus 2, 3, 6 plus 3x. X is the matrix you have to find out. 3x is equal to 5 into matrix B. What is B matrix? 2, minus 2, 4, 2, minus 5, 1. Okay. Now you can do the scalar multiplication. That is 16, 0, 8, negative 4, 2 3s are 6, 2 6 are 12, plus 3x. X is equal to 10, minus 10, 20, 10, minus 25, 5. These two matrices are equal. But when you observe the left hand side, you can see that 3x. X matrix is unknown to you. But there is another matrix. This is a positive matrix. It can be shifted to the right hand side. So this positive matrix, when it is shifted to the right hand side, it becomes a negative matrix. So 3x is equal to 10, minus 10, 20, 10, minus 25, 5, minus 16, 0, 8, minus 4, 6 and 12. So 3x is equal to the subtraction of these two matrices, and which is equal to, how do you subtract the corresponding elements, because these two matrices are of the same order. 10 minus 16 is minus 6, minus 10 minus 0, minus 10. 20 minus 8 is equal to 12. 10 minus minus 4 is equal to 14. Minus 25 minus 6 is equal to minus 31. 5 minus 12 is equal to minus 7. So that is 3 into x. 3 into x, a scalar multiplication. But your question is, what is x? X matrix equal to 1 by 3. This 3 you bring down. 1 by 3 into matrix minus 6, minus 10, 12, 14, minus 31, minus 7. Again, you can say that it is a scalar multiplication. Scalar multiplication. That means each element can be multiplied by 1 by 3. That is minus 6 into 1 by 3. Minus 10 into 1 by 3. 12 into 1 by 3. 14 into 1 by 3. Minus 31 into 1 by 3. Minus 7 into 1 by 3. Okay, because it is scalar multiplication. So what will be the final answer? Each element you are multiplying with 1 by 3, which is equal to minus 6 into 1 by 3 is minus 2. Next will be minus 10 by 3. 12 into 1 by 3 is 4. 14 into 1 by 3 is 14 by 3. If you want, you can make it as decimal or leave as such. Minus 31 by 3 and minus 7 by 3. This is your matrix X. And that is also of the same order as A and B. A and B. I hope all of you have understood this type of questions. Matrix X. Matrix X means it will be always denoted by capital letter. If it is an element X in a matrix, A is equal to, if there is an X, element X, it will be written as small x 2, 4. Element X will be denoted by small letter, but matrix X or matrix Y, it will be denoted by capital letters. So you have to understand the difference between capital X and small x in the case of a matrix. Capital X means it is a matrix. Small x means it is an element of a matrix. I hope you all understood the concept. Yes. Finish copy. Okay. Now we move on to the next one. Find matrix minus 1, 4, minus 6, 8, 5, 16, 2, 8, 5 plus matrix 12, 7, 6, 8, 0, 5, 3, 2, 4. That means you are asked just to add these two matrices. What is the order of the first matrix? 3 by 3. Order of the second matrix is also 3 by 3. When you add, answer is equal to a matrix of order 3 by 3. How do you add? How do you add the matrices? Add the corresponding elements. Yes. Minus 1 plus 12. 11. Again I am doing it mentally. 4 plus 7, 11. Minus 6 plus 6, 0. 8 plus 8, 16. 5 plus 0, 5. 16 plus 5, 21. 2 plus 3, 5. 8 plus 2, 10. 5 plus 4, 9. Yes, and it is of order 3 by 3. Answer. Now, in matrix, you can see, you have already understood that matrix elements can be real numbers or functions. Sin x, cos x, etc. and so on. So, what about the next question? Matrix cos squared x, sin squared x, sin squared x, cos squared x plus sin squared x, cos squared x, cos squared x, sin squared x. You may get this question for 1 mark. 1 mark. So how do you do this? The first matrix is of order 2 by 2. Second matrix is of order 2 by 2. The elements are all functions, trigonometric functions. Now, when you add the corresponding elements. What are the corresponding elements? Cos squared x plus sin squared x. Next one, sin squared x plus cos squared x. Next one, sin squared x plus cos squared x. And the last one, cos squared x plus sin squared x. Add the corresponding elements. Now, in this case, you have to remember the trigonometric identity you have studied in class 11. What is sin squared x, cos squared x plus sin squared x? it is equal to 1. Sin squared x plus cos squared x, 1. Sin squared x plus cos squared x, 1. Cos squared x plus sin squared x is equal to 1. So, this is a 2 by 2 matrix in which all elements are all equal to unity. All the elements are equal to unity. Clear? Okay. Now, when you go home, open your textbook. You can do exercise 3.2, some of the questions, because one more concept is there. Because when you discussed, you were discussing like what are the operations on matrices. Yes, you said it was addition, subtraction, multiplication and division. Okay, so what about addition we have studied, subtraction we have studied. Next concept we are studying about multiplication of matrices. Yes, the next operation is multiplication. Multiplication of matrices. Now, what is the condition for addition and subtraction? If you want to add or subtract, the two matrices should be of the same order. Concerning about the order. Now, what about multiplication of matrices? Is it possible to multiply all matrices together, A and B? Is there any constraint for that? Yes, there is a constraint. Like, let us say there is a matrix A. A matrix means it will have an order. Let us say order is equal to m by n. For example, let it be equal to 2 by 3. 2 by 3. M is 2, n is 3. That means 2 rows and 3 columns. So you can get an imagination. B is a matrix of order. B is a matrix of order n by p. That is 3 by 2. 3 by 2. Or 3 by 2. Okay. Or you can say it is equal to 3 by 1. Anything. 3 by 2 also, no problem. We will discuss questions based on that. Now, when you want to multiply these two matrices, I want to find out matrix AB. Multiplications means matrix AB. Matrix AB means A is the first matrix, B is the second matrix. Now, in that case, number of columns of the first matrix, should be equal to number of rows of the second matrix. Number of columns of the first matrix, column is equal to row. Then the product AB will be a matrix of order m by p. So here the product will be of order. What will be the product? Will be of order 2 by 1. 2 rows and 1 column. Let us take an example. A. Yes, give me an example of a matrix of order 2 by 3. 2 rows, 3 columns. 2 rows and 3 columns. 2, 1, minus 3, 0, 4, 1. 2 rows, 3 columns. And next one, B, is of order 3 by 1. That is 3 rows. 3 rows. 4, 2, minus 4. 3 rows and 1 column. 2 by 3 and 3 by 1. Now, according to the property of multiplication, these two matrices can be multiplied. Now, how can you multiply? first row into the first column. First row into the first column. So it comes like a pattern of 7. You see, first row into the first column. In between, you have to put addition signs. I'll show you. 2 into 4. At once put plus. 1 into 2 plus. Minus 3 into minus 4. That will be the first element. It's done. First row into the first column. Nothing else. Next comes the second row. Second row into the first column. 0 into 4. At once put plus. 4 into 2 plus 1 into minus 4. Done. It is equal to matrix 2 into 4, 8 plus 2 plus 12. 0 plus 8 plus negative 4. And that is equal to matrix 8 plus 2, 10. 10 plus 12, 22. 8 plus minus 4 is equal to 4. And it is of order, it is having 2 rows and 1 column. So, before doing the problem, I was able to say the order of the answer 2 by 1. I was able to say the order of the multiplied matrix. It is equal to 2 by 1. 2 rows and 1 column. So, when can you multiply it, or what is the property for multiplication? 2 matrices are conformable for multiplication if the number of columns of the first matrix is equal to the number of rows of the second matrix. Then the answer will be M by P. We will do one more question. Here we took the first example, 3 by 2. So what is the product of AB? AB, it will be of order 2 by 2. How many elements will be there? There will be 4 elements. Okay. 2 by 3 matrix. A is equal to 4, 2, 3, 0, minus 1, 7. 2 rows, 3 columns. B matrix. 3 rows and 2 columns. 6, minus 2, 4, 1, 3, minus 3. 3 rows and 2 columns. This is 2 by 3 and this is 3 by 2. You have to find out matrix AB. You said answer will be of order 2 by 2. That should be in your mind. That means there will be 2 rows and 2 columns. Okay. How do you do? Always remember the pattern of 7. Row, column. Row, column. So, 4 into 6 plus whatever be the next sign, don't go to think about it. At once put the plus sign. 2 into 4 plus 3 into 3. Done. Then go to the first row and the second column. Leave a space. That is the second element. 4 into minus 2 plus 2 into 1 plus 3 into minus 3. Next one, 7 pattern. First row, first column. 0 into 6 plus minus 1 into 4 plus 7 into 3. Okay. What will be the next one? 0 into minus 2 plus minus 1 into 1 plus 7 into minus 3. Pattern of 7, row, column equal to 24 plus 8 plus 9. I hope all are doing along with me because this is simple addition and subtraction. Do along with me. 4 into minus 2 minus 8 plus 2 plus minus 9. 0 plus negative 4 plus 21. 0 plus minus 1 plus minus 21 equal to 24 plus 8, 32. 32 plus 9, 41. Negative minus 8 plus 2, minus 6. Minus 6 plus minus 9, minus 15. Minus 4 plus 21, 17. Minus 1 plus minus 21 is equal to minus 22. 2 by 2. Okay, so this is how you multiply two matrices. Number of columns of the first matrix should be equal to number of rows of the second matrix. Only then you can multiply the two matrices m by n and n by p. The result will be of m by p. Then suppose if I am asking you, can you find out matrix BA in the same question? I hope this is clear to you. The same question I am asking you. Let us write the answer somewhere. AB is 41, negative 15, 17 and minus 22. This is AB. Now, some students may ask, can you find out only AB? We can find BA also, but the condition should be applicable. What is the condition? 3 by 2, B matrix 3 by 2, A matrix 2 by 3. Can you multiply? Look, number of columns, number of rows equal. But what about the answer BA? BA will be of order 3 by 3. 3 rows and 2 columns. But what about AB? AB is of order 2 by 2. Let us see. But don't do it in a hurry. You write down the first matrix first. 6 minus 2, 4, 1. When you have more practice, there is no problem. But before that, do stepwise. You won't know where you are going wrong. B into A. And you know that the answer, what will be the answer? Answer will be of order 3 by 3. That is 3 rows and 3 columns. Imagine that you should get equal to first row into the first column. 6 into 4. I am multiplying mentally, plus 2 into minus 0. 0. Done. First row into the second column. 6 into 2, 12. Plus minus 2 into minus 1. 2. Done. First row into the third column. 6 into 3. 18. Plus minus 2 into 7. Minus 14. So with first row everything is done. Now come to the second row. 4 into 4. 16 plus 1 into 0. 0. Okay. Next one. 4 into 2. 8 plus 1 into minus 1. Minus 1. 7 pattern. Okay. 4 into 3. 12. plus 1 into 7, 7. Next one, 3 into 4, 12, plus minus 3 into 0, 0. Next one, third row, second column, 3 into 2, 6, plus minus 3 into minus 1, 3. 3 into 3, 9, plus minus 3 into 7, minus 21, equal to matrix 24 plus 0, 24, 12 plus 2, 14, 18 plus minus 14 gives you 4, 16 plus 0, 16, 8 plus minus 1, 7, 12 plus 7, 19, 12 plus 0, 12, 6 plus 3, 9, 9 plus minus 21 is equal to minus 11. Isn't it? What is the answer here? Yes, give me the answer. Minus 12. Yes. And the order is equal to 3 by 3. So, here AB was equal to 2 by 2. BA was equal to, BA is equal to of order 3 by 3. You can multiply. Here you can multiply AB and BA, but you found that AB is not equal to, B is not equal to BA. AB is not equal to BA. That means matrix multiplication is not commutative. Matrix multiplication is not commutative. But what about matrix addition? Yes, matrix addition is commutative, but matrix multiplication is not commutative. Now, for the time being, we will have a short break and then we will continue the class.